Good evening, learners. Welcome to this platform where you have the privilege to learn the sciences and other subjects. Remember, it is only on this platform where you can learn the sciences such as physics, chemistry, biology, mathematics, additional mathematics, in addition to other subjects like agriculture, English, and geography. By enrolling with us, you can learn all the subjects to prepare you for the 2026 MSc exams. My name once again is Mr. Bronsted-Lowry, and welcome. It is our job to make sure that we prepare you well for the coming exams. Feel free to ask questions where I've not made myself clear enough. So leave a comment in the comment section below there, and I'll be delighted to respond to any questions that you might have. So welcome to this topic, which is called acids and bases. I'm sure it's not the first time you have met this topic. This topic is not quite new. It was first introduced to you in Form 2, where you were looking at acids and bases in terms of their definitions, characteristics, and their reactions. At this level, we are going to look at acids and bases with respect to the following objectives. Right? It is my expectation that by the end of the topic, you will be able to define an acid and a base. Your examiners may require you to give a definition of an acid and a base based on some kind of theory. You'll be required also to be able to identify conjugate acid-base pairs from a given equation. You'll be required to explain the difference between the terms strength and the concentration. Strength and the concentration. When we say this is a strong acid, or this is a weak acid, what do we mean? Or when we say this is a highly concentrated acid, what do we mean? So you'll be required to be able to give differences between these two important terms pertaining to an acid and a base. You'll be required to explain ways of regulating pH of different environments. For example, how can you regulate the pH of soil, pH of water, and the pH of the stomach? Okay, we'll talk about this. Then later on, you should be able to classify oxides as either acidic oxides, basic oxides, or amphoteric acids, rather oxides. You should be able to describe different ways of preparing salts. We shall start by looking at the definition of a salt. What is a salt? And the different ways of preparing salts. And then we look at basic experiments that you will be required to design. So you may be required to design an experiment to prepare and purify a salt. Your paper 2 chemistry, which is practical, question 1 or 2, you'll be required to design an experiment to prepare and purify a salt. 10 marks. So we are going to look at that. At the very end, you should be able to state the applications of precipitation reactions. Remember that a precipitation reaction is where a chemical reaction produces a solid product. So we shall look at the applications of such reactions. Great. Welcome to the definition of an acid and a base using a theory which is called Bronsted-Lowry theory. By the way, Bronsted and Lowry are chemists who took keen interest in studying the behavior of acids and bases. And in their discovery, they found out that according to these two guys, the gentlemen, an acid is simply any substance which donates a proton to another substance. That substance which receives a proton is called a base. All right, once again, so according to Bronsted-Lowry theory, an acid is a substance which donates a proton to another substance. Okay, for example, suppose we're looking at an acid such as HCl, hydrochloric acid, may be reacting or mixed with water. All right, so it will be seen that the HCl will donate its proton, hydrogen ion. By the way, a proton is just a hydrogen ion, to form what is called a hydronium ion, H3O with a plus, and what will remain after the proton, the hydrogen, has been donated is Cl minus. All right, so we are saying that any substance that is capable of donating a proton, which is basically a hydrogen ion, is called an acid, according to these two guys, Bronsted-Lowry theory. So, according to Bronsted-Lowry theory, any substance, an acid is basically any substance which can give away its proton to another substance. Okay? So, the proton we are talking about here is basically a hydrogen ion written as H with a superscript plus. So the hydrogen ion, which is H plus, is a proton, which all acids donate. So all acids have one ion in common. That ion is H plus, which is hydrogen ion. So why we call a hydrogen ion a proton is because hydrogen, the simplest form of hydrogen, does not have a neutron in its nucleus. Instead, it only has a proton, which is positively charged. Remember that a proton is a positively charged particle. All right, so when the hydrogen is reacting with another substance, it will give away its electron, but in the nucleus, there is still going to be this ion, which is positively charged, and that's the hydrogen ion. So when an acid is reacting with another substance, what it does is to give away its hydrogen ion. So that hydrogen ion is called a proton. Okay, so what are we saying? We are saying that according to this, the theory generated by Bronsted-Lowry, an acid is any substance which gives away. To donate means to give. So which gives is proton. What is that proton? It's hydrogen ion to another substance. So the substance which receives the ion, the hydrogen proton, the hydrogen ion, which is a proton, is called a base. So we are saying, once again, the hydrogen ion, which is H plus, is a proton which all acids contain or donate. So think of examples of acids such as hydrochloric acid, sulfuric acid, all these, sulfuric acid, nitric acid, carbonic acid, and many other examples. They all donate a hydrogen ion to a base, to another substance which is called base. According to the same theory, the Bronsted-Lowry theory, a base is defined as a substance which accepts a proton, which is the hydrogen ion, from another substance, which is the acid. Remember that the words donate and accept are opposite words. So an acid is a donor, donates. A base accepts. So what is donated is the hydrogen proton or ion, which is called a proton, and the base accepts that hydrogen ion. In other words, an acid is a donor, proton donor. A base is a proton acceptor. There is donating and accepting. So what is donated must be accepted. Let's suppose that I have decided to donate the pen that I'm using to write on my screen here. I'm giving it to you for free. I'm donating it to you. In terms of acids and base, suppose the pen is a proton. It means I am an acid So I'm donating the pen to you, which represents a proton. And if you accept to receive the pen, you become a base. You are accepting the proton, which is represented by the pen I'm giving to you. I hope you are following on this discussion. So once again, an acid is a proton donor. A base is a proton acceptor. The proton donated by an acid must be accepted by a base. For example, let me give you an example. Let's suppose that an acid such as hydrochloric acid, once again, HCl, is reacting with ammonia. Ammonia, which is a base, is NH3. The hydrogen ion is going to be given to ammonia. In this case, hydrochloric acid is an acid, as the name suggests, and since the hydrogen ion is being received by ammonia, so ammonia in this case is a base. So that in the end, once the hydrogen has been donated, what will be left of it is Cl- without hydrogen attached on it. The hydrogen is no longer attached to the chloride ion, it is donated to ammonia. So initially, you see here that the ammonia had 3 hydrogen atoms. Now, the product thereof is going to have 4 hydrogen atoms. Where has the other hydrogen come from? It has come from the acid HCl. Okay, so you end up forming what is called hydronium. No, this is called ammonium ion with 4 hydrogen atoms. Why 4? At first, there were 3. Why has it now become 4? It's because 1 hydrogen, which is proton in this case, H+, has been donated by HCl, So once again, if anyone asks you what is an acid, simply say an acid is a hydrogen donor. What is a base? It is a hydrogen proton, an acid is a proton donor. Okay, proton donor. Remember, a proton is H+. An acid is a proton donor. A base is a proton acceptor. So the proton donated by an acid must be accepted by a base with which the acid is reacting. I hope so far so good. So we've looked at the definitions of an acid and a base using Bronsted-Lowry theory. So let us look at an illustration just to further explain the meaning of acid and base. So we are saying, to get this much clear, the concept of an acid as a proton donor and a base as a proton acceptor. Let's look at the picture shown below. This picture shows 2 girls of the same team, football team, passing a ball to each other during a football match. So look at this picture, we have two girls here. We have this girl 1 who has the ball. He has a ball possession. She is possessing the ball. The ball is with her at this moment. Okay, since girl 2 is with her in the same team, the two are in the same team. Okay, so in order to score, girl 1 must pass the ball to girl 2 so that she can also pass it to another person and eventually score a goal. So suppose that the ball represents a proton. So in this case, girl 1 is going to act as an acid. And when she passes the ball to girl 2, now you can see the result is that at any given time, girl 1 is no longer having the ball. Where is the ball now? The ball is now with girl number 2. And the girl number 2 is also figuring out who she has to pass the ball to. So in this case, girl 1 is acting as an acid, and the ball is acting as a proton, which is hydrogen ion. So girl 2 in this case is going to act as a base to accept the ball. Okay, so at any given moment afterwards, girl 1 does not have a ball anymore. In other words, the acid has donated its proton, and now it does not have that proton anymore. Where is the proton? The proton is with girl 2. This is just an illustration to show you the concepts of a proton donor and proton acceptor. I'm sure the illustration has helped you to understand what we are talking about. All right, so far so good. We've looked at the definition of a base. We've looked at an acid and the base. So define the term acid according to the Bronsted-Lowry theory. We just saw that. Again, define the term base. This should be base. Define the term base according to the Bronsted-Lowry theory. Okay, so I would like you to write the definitions in your own understanding without repeating the definitions that I gave you earlier on. And please share your answers with me to my number. I'll be glad to receive your responses. 0981258577. Remember that it is the same number that you shall need to use in order to reach me in case you'd like to order lessons. I'll be glad to attend to you and make sure that you get what you want. So we are saying, define the term acid according to the Bronsted-Lowry theory, and define the term base according to the Bronsted-Lowry theory. Then give examples of common acids and bases. Okay, I look forward to receiving your responses. Please make sure you write on a paper, take a picture of your answers and send to me. Then I'll be able to score your work and probably give back feedback. My name once again is Mr. Pochilola. Thank you very much for considering to learn from me. I don't take this for granted. Invite your friends, as many of them as possible. I'll be glad to teach you. Thank you very much for now. Bye-bye. Let's meet in the next lesson.